Containers. Meet the cloud's evolution before throwing ourselves into Kubernetes. There is something we need to understand. And the first basic thing is container. Containers. Meet the cloud's evolution before throwing ourselves into Kubernetes. There is something we need to understand. And the first basic thing is container. What is a container? Section 1 Traditional deployment. Remember thousands of years ago, when you finished the project's development process, you'd go to a server hosting provider and ask for a new server, or just a space on their servers. After paying your hosting, you start uploading your code, setting up your database into it, and voila, your project is online. Simple and naive. It's called traditional deployment, where your applications are set up to run directly on physical servers. There is no text on this page. Traditional deployment, 1000 years BC. We call traditional deployment, where your applications are placed on top of an operating system, which runs directly on physical servers. If you rent an entire server, dedicated hosting, you have full controls of your servers, including hardware, CPU, GPU, RAM, storage disks, software, operating system, libraries, and network connections. Your servers are placed inside data centers, along with others. Data center, or if you just rent spaces on servers, shared hosting. Your application shares servers resources with other neighbors. You have limited controls over your spaces, and almost depended on the server's global configurations and libraries. Shared hosting versus dedicated hosting. Section 2 Virtualized deployment. Time was passing by. Paying for a dedicated server is pretty high, plus the management cost, maintenance fee, or even if you hosted your website together with others for saving money, sometimes your neighbor's website could crash the entire server. You started to think about a new option. Virtual Private Server, aka VPS, your virtual dedicated server with lower cost and less management pain. Seems you can sleep well now, without worrying about your neighbor's applications. There is no text on this page. Virtualized deployment, Renaissance 15th-16th century, and it's called virtualized deployment, which allows you to run multiple virtual machines, VMs, on a single physical server. With traditional deployment, there was no way to define resource boundaries for applications in a physical server, and this caused resource allocation issues. For example, if multiple applications run on a physical server, there can be instances where one application would take up most of the resources, and as a result, the other applications would underperform. A solution for this would be to run each application on a different physical server. But this did not scale as resources were underutilized, and it was expensive for organizations to maintain many physical servers. Beside it, hosting multiple applications on the same operation system could cause potential security vulnerabilities, where a vulnerable application could bring access to other applications living on the same server. Shared hosting versus virtual private server. With virtualization technology, now we can have applications isolated between VMs and provides a level of security as the information of one application cannot be freely accessed by another application. Virtualized deployment allows better utilization of resources in a physical server and allows better scalability because an application can be added or updated easily, reduces hardware costs, and much more. With virtualization, you can present a set of physical resources as a cluster of disposable virtual machines. Each VM is a full machine running all the components, including its own operating system, on top of the virtualized hardware. Section 3 Container deployment. And again, after hundreds of years using VPS, you and your crew were facing many new problems with the VPS dream. Black small square, virtual machine, VM, contains the full OS. It's very heavy for backup. Snapshot. Black small square. Spin up a new VM could take minutes. It's unacceptable for our era. Black small square. For every VM, besides resources, CPU, RAM, disk, for your application, you also waste those resources for the OS, and they are not cheap when your applications require many VMs. Black small square. Wait, listen. Also, your development teams are complaining about the differences between their development environment versus production environment. Welcome to the 21st century with Container, a new way to create a virtual isolated environment for your application. Black small square. A container provides an isolated environment which runs your application, independent from the host OS. Black small square. The container stays on top of a container runtime, shares the resources, libraries, with the host OS. So you aren't running an entire isolated OS on the host OS, but you're running an isolated application on the host OS. Black small square. Spin up a new container in milliseconds. Imagine if your server is under high load, you can just put more 10 servers under your load balancer in just some milliseconds. Container deployment. 21st century. This model is called container deployment, where you run your applications inside separated environments, built on top of the same operating system. Containers are similar to VMs, but they have relaxed isolation properties to share the operating system, OS, among the applications. Therefore, containers are considered lightweight. Similar to a VM, a container has its own file system, CPU, memory, process space, and more. As they are decoupled from the underlying infrastructure, they are portable across clouds and OS distributions. Containers are designed to run your application, and there is Kubernetes designed to manage your containers efficiently. In the next chapters, we will work together on a simple PHP project, from local development with container to server deployment with Kubernetes. Chapter 2, Local Development with Containers. Let's start everything with a really simple PHP project. Don't worry if you are not familiar with PHP. Trust me, it's really simple. Section 1, Project Requirements. Our project is a single web application, which prints all PHP configuration parameters upon request. That's it, nothing else. If you want to read more, simply check the documentation here. https www.php.net manual and function pinfo PHP. We'd like to deploy it into our servers. We have 2 servers running whatever Linux distro, let's say Ubuntu 18 LTS. Our imagination dev team is using PHP. One uses PHP 5. Don't worry, he is our key person for 100 years. Someone uses PHP 7.17.27.37.4. They are also using different OS. Yes, your best dream team ever. Marketing team planned a big launch event, expecting 1 million people will visit our website, well, to see our PHP's info. So we'd like to have a load balancer, but really, nobody knows how many servers we should put behind and wait. We don't want to bring up 100 servers running in the midnight to serve nobody. Sometime, for some funny reason, fpinfo just crashed PHP, FPM, and your testers were seeing some not so nice 5xx errors from ginks. What we're gonna do, just put the file, config ginks, PHP, FPM, spin up a load balancer with 100 servers behind, and pray? There is no text on this page. Hell no, Phil Coulson, of course not. We're living in containers era. Let's try to do in the best way with containers. Section 2, Docker development. We're gonna start everything with the development team. Everyone, please install Docker. https www.docker.com, your new friend, who will help you to make it easier to create, run, and deploy applications by using container. I don't care about your OS, your PHP installation. We're gonna work with the same environment as we have on production. PHP, FPM 7.4. While our devs are busy downloading and installing their new friend Docker, let's init the repository. The Docker file you have here is a definition for your container, where you create the environment for your application. Pretty simple, huh? My environment is based on PHP 7.4 FPM, a PHP official Docker image version 7.4 with PHP FPM. It means you're gonna create an environment which has PHP FPM 7.4. Line 1. I create a new directory called app, where I'm gonna put my application. Line 2. I want to set the current working directory to app, so everything I'm gonna do from now is for the directory app. Line 3. Finally, I want to put our codebase, which is located under directory src inside the repo, into the working directory. Line 4. Done. We've just created our first Docker file ever. Just that, with 4 lines. You defined the environment for your dev team and also for our production server. It's almost ready to start developing our application. Let's wait for the dev team finishes and pushes their codebase into the repo. Okay, so we're ready to run. First of all, we need to package our application codebase along with our environment. Open a terminal console in the project directory and run this command. Make sure you've installed Docker. The command above will build your first Docker image, which contains the codebase and PHP